All right, so we're going to look at activity, linear regression and correlation. As always, remember the first thing that you want to do is to select File, make a copy, and then rename it. All right. I'm going to take you through a few examples. We're going to use some of the more advanced features in Google Sheets. So it's really kind of important that you follow this process step by step. All right. So you'll see here that I have a tab for examples and a worksheet associated with those examples. So if you go into the worksheet, we have three examples here. You go into the examples worksheet, you could see that there's workspaces for each of the examples. I just caught a little typo here. All right. And, we'll get into solved examples and the assignment itself, but for now, let's just work through these examples. All right, suppose we hypothesize the number of doctor visits a person has can be explained by the amount of cigarettes they smoke, which is hopefully zero, but it's the world we live in. We want to see if there is a relationship between the number of cigarettes one smokes a week, which we would call the explanatory or independent variable, just thinking back to Unit 2, and the number of times per year one visits a doctor, so that's the response variable or dependent variable. We ask 10 random people and get the information below. Find the strength of the linear correlation. Find the equation of the least squares line, right? So linear correlation coefficient, essentially, and the line that best fits the data, right? So I'm going to go into my examples worksheet. I'm going to take note that this information here is in cell, or starts in cell A2 and goes to B12. So here, I'm going to paste my information, but I'm going to do it by cell references rather than just copy paste. So equals, the first one's in A2. Sorry, ahead of myself here. The first one is in this cell's A2, or this sheet's A2, and I hit return, and it'll populate it there, drag down, and it'll pull the information from that column. So we'll do the same thing for B2. So equals, you can take what we did here and just modify it, but I'll just do it again anyway. So examples B2, paste and drag. All right. Now, in order to find the correlation coefficient mathematically, that's the important distinction here, because there are built-in functions for Excel and Google Sheets, but we're not going to use those. I want to have a kind of a living worksheet here. So I'm just thinking down the line when you're putting together your final project, that you could take this file and just change the values here, or even change them in here, and everything else will correspondingly change. Right? So you see this formula, x minus x bar over sx. So we need an x bar, which is the same as the average. All right, so equals average. And it's a question of average of what? Average of these values. We're not very often going to be using the autofill, just because each line corresponds to a unique command or operation. So X that out. SX, that's the sample standard deviation, so equals sample, so, standard, and then just go and find the one that has the dot S. Again, copy or highlight the appropriate data. And you can see we have this command. If we want, we just change these A's to C's, or we just do the process again. Y bar means the same, or has the same conceptual meaning as X bar, except it's related to the variable Y as opposed to the variable X. So average, standard deviation, but for the sample. And you'll notice I stopped closing parentheses because I'm not typing anything after this. Excel and Google Sheets know that I'm done with it, and that there's an implied close parenthesis. So lock it in. We're going to get x minus x bar over sx for each one of these. And what this is it's the z-score. So we did this back in Unit 1. You compute the z-score between a value and its mean, well, it standardizes it. So what we're looking at is how far, in terms of standard deviations, a particular value is away from the mean, right? And we also learned that if the z-score is greater than 2 or less than -2, then the corresponding x value, and we'll see in a little bit the y value, those corresponding values would be unusual. All right, so it's useful to do this computation, even though there's a feature in Google Sheets that'll just spit out the b value, the a value, the line of best fit, the correlation coefficient. Like it'll do that. The issue is in terms of like knowing what's going on along the way, because it's very rarely going to be a situation when you're doing statistical analyses that you're going to just want one number, right? Odds are you want a bunch of different things. So going back to gas prices, we knew which gas prices were unusual. On the low side is good, on the high side is bad, because we did this process. So it's essentially the same thing. So I'm going to click equals, open parentheses, my x value's in here, minus my x bar, which is here. Now I don't want that to change when I drag it down the line, so I'm going to put $signs on it. Then divide by my standard deviation, which I also don't want to change. All right, the only thing I want to change is the A3. When I drag it down the line, I want it to become A4, A5, and so on. This line command will take care of that. And actually, in this case, you could use autofill, but if you don't trust it, then just drag the little handlebar, and you'll see it gives the same values anyway. Now, in terms of the quality of these decimals, it is pretty hideous. So let me back up here for a second. I don't need that many decimal values. So what I'm going to do in front is I'm going to tuck in a round, put another set of parentheses. I have my operation, comma, what I want it to round to. There's other ways to round, but if you want the system to do it automatically, this would be the best way, at least in the early going. So I want it to go 3 decimal places, so I'll type in a 3, close parentheses, and it gave me 3 decimal places, including the 0. If I want to go further, you see, if it will round away down to, let's say, 2 decimal places, then that would happen. That's what I was saying. It accounted for the 0 here. Let me put it back to 3. So it's saying 850, but it's, the system recognizes that, well, 0.850 and 0.85 are the same, right? So we're good there. If you drag it down the line, you see some of them have 3 decimal places and some of them have 2, all right? Do the same thing for y. I'm going to copy paste this. I'm going to put it in here. I want to reference, instead of A3, I want to reference C3. I want to call on my Y bar and my SY. My Y bar is in H5, and my SY is in H6. So lock it in. I'll accept the autofill. I like to have it centered. It just looks a little nicer, so go ahead and do that. This column is telling us to multiply the entries from this column and this column. So that's a little bit more basic. So I'm just going to take this number, multiply it by this number. All right, we still get a lot more decimal places than we really want. So you can accept it because it's not going off the, I was going to say off the page, but really it's not going beyond the width of the cell. In the other cases, it was, so that was kind of an issue. But here, it's not that bad. So you don't have to throw it around here if you don't want, but you can also. So you just use your best judgment on that. All right. So if I go over here, you see I have B equals So we're looking for a B, R, which we don't have, SY, SX, which we do have, that's over here. So I need an R value. So going back to this formula, R, or going to this formula, R is equal to, and just a quick aside, this is a scary looking formula, but it's really not that bad, because what it's saying for this funky symbol, that's the summation, it's saying add up what you would get for your x minus x bar over sx, which we have here, multiplied by your y minus y bar over sy, which we have here. That product is actually right here. That sum is just telling you to add up these values. All right. The 1 over n minus 1, that's just division and subtraction. That n is the number of values in the set, right? Number of pairs of data. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could, if you want, just put a 10 in for n. But if you want this to be flexible, more dynamic, then use a count function instead. So what I would do here is type equals count, highlight, close it up, enter. Get rid of the suggestion. There are 10 values there, but I didn't actually have to physically count them. Now, for a data set that only has 10 values, not a big deal to count them, but if there were 1,000, obviously you're not going to want to go through and count them all up, right? I mean, you could use your row references to help you do that, but there's a count feature, so why not use it? So I'm going to type in equals, I'm going to do 1 over n minus 1, so in parentheses, 1 divided by another set of parentheses, my n minus 1, close it up. That takes care of this part here. All right. Now I'm going to multiply that by the sum of the product of these two expressions, and that sum relates to this column here. So close it up. We have 1 over n minus 1 times the sum of everything in this column, which it's the data analysis for x minus x bar over s, y minus y bar over s also multiplied. So I'm going to hit enter, and that's my correlation coefficient. The closer this number is to 1 or -1, the stronger the relationship is. So we're looking at a very strong relationship between the two variables here, right? Now to get my b, I'm going to type in equals the r value we just determined multiplied by the sy divided by the sx. So open parentheses, sy divided by sx. Lock it in. See, I have unwieldy decimal values, so I'm going to just dial that back using a round. So I'm going to round that numerical value to 3 places. You can go 4, you can go 5. I mean, you could go as high as you want to fill the space. It's up to you. It's just I tend to default to 3 decimal places. Now a is equal to my y bar minus my b value right here times my x bar. And rounding wise, this looks pretty good. In terms of my LSRL, my least squares regression line, also known as the line of best fit, I'm going to have a y hat, which is a really weird expression, but it's the appropriate way of representing a line of best fit, is equal to a plus bx. Now, I don't want to type it in here. I want to make use of all the calculations that were already made. So, I mean, you will have to type something, but I want it to change. I want this answer to change along with any changes in the data. And I'll just, as a quick aside, let's say I had 40 doctor visits instead of 4. See how everything changed along with it? That's how we want it to be. And you'll see that that'll be true for the LSRL in a second. So equals, we're going to type in concatenate. And concatenate just means that you're taking different string elements and putting them together, right? When we talk about strings, we're talking about like words instead of just numbers, right? Other characters are possible too, like if I wanted to use a $sign or an ampersand or a pound sign or whatever, I could use concatenate to put those things together. So, and you'll see in a second. I'm going to type in quotes anything that's not a numerical cell. So I want this to say y hat equals a plus bx. So open a set of quotes. I'm just going to paste in that y hat. Throw in an equals, so space equals, another space. Close it up. And let me just actually show you what this would look like. If I close it up and hit enter, it would produce a y equals. It's not a numerical value. It's just a string of characters. But I want to go further. I want the A to appear, which is in this cell, so I'm going to do comma and then click on the A. Let me show you what that looks like. Now it says y hat is equal to whatever the A value is. I want it to be A plus the B value times the X value. So let's go back in and continue. Comma. I'm going to open up another set of quotes. I'm going to put a plus sign in. And if it doesn't look right, you could always go back and edit. But generally, if I have a numerical value and I wanted to have some spacing, what I would do is put a space in and then my symbol and then another space. So let's take a look at that. See how it created that space there? If I didn't do that, you'd have this where the plus sign is basically attached to the A, which may or may not be a big deal. In a lot of cases it doesn't matter, but sometimes it will. All right. So comma, my B value, and again, we'll see what it looks like. Good. Now I just need to get an X on there. All right. So comma X. This time I don't need a space because I want it to actually be adjacent to the K3, the B value. Lock it in, and I have my equation, a line of best fit. I can expand here to make it look a little better, but then it kind of makes this look a little wonky, so it's up to you. What it could do instead, oh, sorry, overdid it. There we go. What I could do instead is just make this left justified and then just highlight these other two cells. That's really just for appearances. You don't have to do that if you don't want to. But that's the solution to the first example. Now, if I go back in and I make these, 10, 10, 20, whatever, it doesn't really matter what you make it. You see that these values changed correspondingly. All right, so I'm going to put it back the way I found it. And that's our solution to the first problem. So now we're looking at the second example. This one talks about cost of mountain bikes versus their rating, review score, however you want to think of it. We're looking for, again, strength of the linear relationship, equation of the least squares line, and then a graph. All right, so this information starts in, the relevant information is B16. So I'm going to copy my information over. So equals examples B16, and then the second set of data is in C16. So I can do this if I want. There's a bunch of different options. Right, and then we could drag it on down the line. We got to fill out this table, but what I'm going to do here is I'm going to get a little sneaky. I'm just going to copy and paste, and just double check that it's referencing the right stuff. All right, so close. It starts in the right place, but it doesn't end in the right place. So this is going to be A41. So references will be 41 instead of 26. It's, I wouldn't say it saved us a great deal of work, but it saved us a little bit, so that's something. I'm going to copy this, right? So just copy, ordinary copy paste, and then just change my references as we go. So A17, correct. We don't want it to go to H3 because that's from the previous data set. I want it to go H17 and divide by H18. Same idea here. Paste it in. This is now H19, H20. Oops, I declined the suggestion, but I didn't need to decline it because it was perfectly fine. All right. The product, so copy, paste, see if it points to the right stuff. B and D, yep, so we're good. Copy it down the line. So in a much quicker fashion, we're able to populate this, this worksheet. Same idea here, copy, paste. Let's see, it says there's 10 values. That's not true because it's not counting all the way to row 41. This is not something that we need. I'll get my R, Command C, Command V, have a look. So it correctly identified the end value. Sum of E17 down to E26. So again, that row reference should become 41. And now I have my R value. Copy, paste. Layout's really important when you use row references because when I copy paste, Excel and Google Sheets tries to figure out whether the relationships are still the same, right? So that's why it's pretty easy to pick up. Like in most of these cases, it would start with the correct row. It thought I was only working with 10 data points, so it only gave me 10. I'd have to make that adjustment, but you're usually in a place where you're where that's the extent of it. You know, you make the adjustments, not code it from scratch. All right, so let me click on the stuff here. Is it pointing to the right stuff? Based on the formula, which for some reason you can barely see here. My R value, yep. My SY, yep. My SX, yep. And the 3 is for the rounding, so we're good there. Copy, paste. It's pointing to the right stuff. Yep. So we're good there. Copy, paste. Same idea with the shading. Make it look nice. Let's see, yep, pointing to the right stuff, so we're good. So we streamlined the work a little bit. And then in terms of making the graph, I mean, if you want, you can copy paste that too, but we have to change labels and everything else, so we might as well just do it from scratch. So insert, chart, same deal, scatter. Select the data, where's my data? It's in examples. Going from, I believe it was B17 to C41. I can take a look. B17 to C41, yeah, so we're good there. We have our graph, label it up and make it taller and you'll have what you need. All right, you can get it to be the same size. You see how it tries to match it up with the previous graph, which is good. Edit, let's go tall. Let's get it on up to 100. See if that captures everything. Not 10, 100. All right, then we get our labels. The first one was price and the second one was rating, so price in dollars. Oh, well, this would be rating because that's the second one. Vertical, horizontal, price in dollars. And there's our second graph. And you can see it corresponds fairly nicely with the R value. It's definitely not linear, but it is following a pattern. Right. So we'll move on to example 3 in a second. We're looking at the third example now. We're going to get information from our final project spreadsheet. I want 10 values, and we're going to find the linear correlation, the strength of that relationship, and also graph the scatter plot. All right, just to have that there. All right, so you can go into your final project spreadsheet. For example, this is an example. You could copy paste it, like do a raw copy paste, but you could also, and for this assignment, I'm going to ask you to do it this way, use the import range function. All right, so I'm going to type in equals import range, and what it's going to do is it's going to link this spreadsheet to the other spreadsheet. All right, so I'm going to open quotes. I'm going to go into the spreadsheet that I want to pull information from, click share, anyone with the link viewer, copy link, then paste. Right, get that link. Now, if you're sharing the spreadsheet with somebody else, you're doing an import range for somebody else, they'd need to have editor permissions in order for you to do that. But since you're referencing a spreadsheet that you own from another spreadsheet that you own, you could leave it as viewer, right? Comma, open quotes. We need to tell it what tab and where to find the data. So the tab is all data, and we want to go from A1 to C11, all right? So all data, exclamation point, A1 to C11. Close the quotes, close parentheses. It'll say loading, it takes a second, but it is now linked to this area of the spreadsheet. So if I make a change here, for example, I change that to some absurd value, it makes the change over here. There's a little lag involved, but it's nothing too terrible. Oops. I hit undo for some reason. I wanted to hit undo here, but not over there. All right, so it's back to where it was. Now these two, I can't really see the heading, so I'm going to make it left justified. And now we have these data points. All right, so we go into our worksheet here, and we're just essentially going to follow the same process. All right, so you can try to copy paste from here. Sometimes it works, sometimes it doesn't. I'm going to just go from the beginning. I'm going to copy paste where it makes sense to copy paste, but I'm going to populate the information the way we did previously. All right, so I don't need the dates. I need the high temperature, and I need the low temperature. Drag it on down the line. And you can go piece at a time here. This example here had 10 data points, so if you want, you can just try to copy and see what happens. Maybe it'll work. This seems different from what it is up here, so we got a fighting chance anyway. Let's see what it's pointing to. All right, it has the right X value, but it's pointing to the wrong X bar and X values. All right, now I could do that over here, or I could just at least direct it to the right location. This should be H48 for the mean and H49 for the standard deviation. So it's pointing to the right stuff, and when I put numbers in here, it'll get appropriately called over here. For now, it's going to say division problem, but whatever, we'll just leave it at that for now. Same idea here. I'll just take 2 of them. I'm going to get greedy, paste it in. Let's see here. Yep, so we want that to be 50 and 51. All right. And then this will be based off of these two calculations, and it's pointing to the right stuff, so we're good. All right, don't be alarmed by the division by zero stuff. I'm still gonna drag it down. Alternatively, you could figure out all this stuff first, but working from left to right, I wanna see how much I can get away with. All right, so does this point to the right stuff? Yep. 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 And yep. All right, so we're good there. Copy paste this. Now we're really getting greedy. Pointing to the right stuff. Yep. Yep. And yep. All right, so we're in good shape there. I'm gonna grab this. Nope, didn't go far enough. Let's see, pointing to the right stuff. Yep. So we're good there. Pointing to the right stuff. Yep. And finally, actually I'm going to take the highlighting too because I've had to do that twice already. Pointing to the right stuff. Yep. Now my decimal got a little crazy here, so I'm going to throw a round on this so that it cleans it up a little bit. Right. So now we have the line that best fits the data, and we'll learn about what we're going to do with that information down the line, but for now it's just a matter of getting it. Now the graph, insert, chart, scatter plot. The information, we'll just go back to the examples page. That could be found going from B45 to B55. So examples B45 to, I think I said B55, I meant C55. All right, so we got a scatter plot, looks somewhat linear, which is good. Customize. High temperatures and low temperatures. So high temperatures. And low temperatures. Then we can resize to fit. Just kind of, I'm going to drag it up here a little bit for a second just to get the size relationship right. It's kind of going off the grid, but let's see. Why does it keep moving there? That's a heck of a question. Yeah, it's being difficult. Let's see if I can do it this way. There we go, a little bit better. And then just drag it back down, and we have a graph to go along. And I didn't have to adjust the axes, which is nice. We have a graph to go along with our calculations. All right, I'm gonna zoom out a little bit just so you can see. We have calculations graph, calculations graph, calculations graph. All right, so we've satisfied all the requirements, and so there it is. So now at this point you can move on to the assignment, and you'll see that it's basically doing a lot of this stuff, but on your own.